Fight response. The fight response begins when the amygdala detects a threat that appears manageable through confrontation rather than escape. It immediately signals the hypothalamus to activate the sympathetic nervous system, releasing adrenaline and noradrenaline that increase heart rate, sharpen visual focus, and redirect blood flow toward the upper body for strength and coordination. One hidden advantage of this response is accelerated decision commitment. Under stress, the brain temporarily reduces hesitation signals from the prefrontal cortex, so action can occur faster when timing matters. Evolutionarily, this allowed early humans to defend territory, protect offspring, and maintain access to food and shelter during conflict. In modern environments, the same response supports assertiveness, protective leadership, and the ability to intervene quickly when others freeze. It also increases temporary pain tolerance by suppressing competing sensory signals, allowing continued performance during emergencies. Rather than representing aggression alone, the fight response reflects a survival system designed to preserve safety through decisive engagement and confident boundary protection. Flight response. The flight response activates when the nervous system determines that distance offers the highest survival probability. The hypothalamus triggers adrenaline release while breathing deepens and circulation shifts toward the legs to support rapid movement. Peripheral vision widens, so escape routes become easier to detect and evaluate. One hidden advantage of this response is strategic foresight. Individuals with strong flight pattern coping often develop heightened awareness of exits, alternatives, and environmental change patterns because their brain constantly rehearses movement options. Evolutionarily, escaping predators and unstable terrain preserved energy and prevented injury when confrontation was unnecessary. In modern life, this response strengthens the ability to disengage from harmful environments, recognize when persistence becomes risk, and relocate toward healthier conditions. It supports adaptability rather than avoidance, allowing the nervous system to prioritize long-term safety over short-term confrontation when movement creates better outcomes. Freeze response. The freeze response occurs when the brain pauses movement to gather additional information before selecting whether to fight or flee. During this state, sensory processing increases while visible motion decreases, allowing attention to shift towards subtle environmental signals. Heart rate briefly stabilizes, and breathing becomes shallow to reduce detectability. One hidden advantage of freezing is enhanced perception accuracy. When movement stops, the brain reallocates energy toward monitoring tone changes, body language, and spatial cues that might otherwise go unnoticed. Evolutionarily, predators often tracked motion more easily than stillness, making freezing a powerful concealment strategy. In modern settings, this response supports careful observation before action and prevents impulsive reactions during uncertainty. It creates a neurological pause that allows the brain to gather critical information before committing to a direction, strengthening judgment rather than weakening performance. Fawn response. The fawn response activates when the nervous system determines that cooperation and social alignment reduce threat intensity more effectively than confrontation or escape. This response increases sensitivity to facial expression, tone shifts, and interpersonal cues because the brain begins scanning for signals that influence relationship stability. One hidden advantage of this response is alliance preservation. Humans evolved in cooperative groups where belonging improved access to shared resources and protection, making social harmony a survival priority. As a result, the nervous system developed pathways that encourage appeasement behaviors when conflict risks exclusion. In modern environments, this response strengthens negotiation ability, emotional intelligence, and conflict de-escalation skills. Individuals with strong fawn responses often become skilled communicators who maintain group cohesion during stressful moments. Rather than representing weakness, this response reflects a biologically efficient strategy for preserving safety through social coordination and cooperative stability. Crying response. Crying activates emotional expression pathways that help regulate stress intensity through parasympathetic nervous system engagement. Emotional tears contain measurable stress-related biochemical byproducts, including cortisol metabolites, suggesting crying contributes to restoring internal balance after overload. One hidden advantage of crying is recovery acceleration. After crying episodes, breathing slows, heart rate stabilizes, and vagal nerve activity increases, shifting the body out of survival mode activation. Crying also functions as a social signal that communicates vulnerability and increases the likelihood of receiving support from others nearby. In early human communities, this signal helped coordinate caregiving responses during injury, illness, or emotional distress. Today, crying continues to support emotional regulation by releasing accumulated tension and strengthening connection pathways that improve resilience. Instead of representing loss of control, crying reflects a built in reset mechanism that helps the nervous system transition from threat mode back into regulation. Shutdown response. The shutdown response activates when the brain determines that neither confrontation nor escape will improve safety. Instead of preparing for movement, the dorsal vagal branch of the autonomic nervous system reduces energy expenditure and lowers emotional intensity. One hidden advantage of shutdown is overload protection. By decreasing sensory input processing and reducing emotional reactivity, the brain prevents stress hormones from overwhelming memory systems and decision-making circuits. Evolutionarily, this response allowed humans to endure extreme danger by conserving energy until safer conditions returned. In modern environments, shutdown responses help individuals tolerate overwhelming experiences without long-term disruption to cognitive stability. This response reflects a conservation strategy that protects the nervous system when immediate action would increase risk rather than reduce it. Hypervigilance response. Hypervigilance increases environmental monitoring by strengthening communication between sensory processing regions and the amygdala. Attention shifts outward continuously, scanning for changes in sound, posture, movement, or tone that might signal risk. One hidden advantage of hypervigilance is early warning detection. Individuals experiencing this response often recognize subtle shifts earlier than others, allowing preparation before threats fully develop. Evolutionarily, this ability improves survival by increasing detection of predators and environmental hazards at earlier stages. In modern settings, hypervigilance supports strong situational awareness in caregiving, leadership, and safety-sensitive roles where noticing small changes matters. Rather than simply reflecting anxiety, hypervigilance represents a nervous system trained to prioritize readiness and pattern recognition when uncertainty increases. Startle response sensitivity. The startle response is a rapid reflex generated in the brainstem that prepares the body for immediate movement when unexpected stimuli appear. Muscles contract automatically, posture adjusts, and blinking protects the eyes before conscious awareness develops. One hidden advantage of this response is reaction speed. Because it operates below voluntary control, protective movement begins within milliseconds of detecting sudden change. Evolutionarily, this reflex prevented injury from falling objects, sudden animal attacks, and unstable terrain hazards that required immediate adjustment. In modern life, startle sensitivity improves performance during driving, athletics, and emergency response situations where rapid reflex timing reduces injury risk. This response reflects the nervous system's ability to prioritize protection through immediate readiness before conscious planning begins. Acute dissociation response. Acute dissociation temporarily reduces emotional intensity when stress becomes overwhelming, allowing cognitive processing to remain functional during high-pressure situations. Perception may feel slightly distant, but attention stays focused on immediate priorities necessary for safety. One hidden advantage of dissociation is cognitive preservation. By lowering emotional overload, the brain protects hippocampal memory systems from stress interference and maintains access to problem-solving pathways. Evolutionarily, this response supported survival during injury or extreme environmental exposure by preventing panic from disrupting action. In modern emergencies, temporary dissociation allows individuals to remain functional until safety returns, and emotional processing can resume later. Rather than representing disconnection alone, this response reflects a protective neurological buffer that preserves performance during overload conditions. Seeking proximity response. Seeking proximity activates when the nervous system encourages movement toward trusted individuals during stress. This response increases oxytocin release, which reduces threat perception and strengthens feelings of safety through connection. One hidden advantage of proximity seeking is cooperative resilience. Humans evolved as group-oriented survivors, meaning safety often depended on shared awareness rather than individual strength alone. Moving closer to supportive individuals improved coordination during danger and increased survival probability across generations. In modern environments, proximity seeking strengthens communication, improves emotional recovery speed, and reinforces trust based regulation signals that stabilize the nervous system during uncertainty. This response reflects the brain's recognition that connection itself is a powerful biological safety strategy. Orienting response. The orienting response shifts attention immediately toward unexpected environmental changes by increasing sensory processing speed and directing visual and auditory focus toward possible threats or opportunities. One hidden advantage of this response is rapid learning adaptation. Because the brain strengthens memory formation during novelty detection moments, orienting responses help individuals adjust quickly to unfamiliar surroundings. Evolutionarily, this response improved survival by ensuring early humans noticed approaching animals, shifting weather patterns, or unfamiliar sounds before danger fully developed. In modern environments, orienting responses strengthen adaptability and awareness in fast-changing situations where attention flexibility improves performance and safety simultaneously. Protective posture response. The protective posture response automatically positions the body to shield vulnerable areas such as the head, neck, and torso during sudden stress. Muscles tighten around vital regions while shoulders lift and arms move inward to reduce exposure. One hidden advantage of this response is injury prevention efficiency. By preparing the body for impact before conscious awareness develops, protective posture adjustments reduce damage during unexpected falls, collisions, or sudden environmental movement. Evolutionarily, this reflex increased survival long before deliberate planning could occur because it protected organs essential for continued functioning. Even today, this response reflects the nervous system's ability to prioritize structural protection instantly when danger appears, demonstrating how deeply survival intelligence is built into human movement patterns. Keep learning, keep embracing what makes you unique. Subscribe and explore the science that makes you extraordinary.